Now, design a push-down automata for the language L is equal to a power n c b power n such that n greater than or equal to 1. Now here our aim is to design a push-down automata to accept all the strings belonging to the language L. Okay. What is the pattern of these strings? So here the strings have equal number of A's and B's, and all A's are preceded by all B's. At the center there is a C. So if we take any string in the language, this pattern is followed by the strings in the language. So what are the possible strings in the language? If the string is going to take value 1, it is ACB, AACBB, AAACBBB. So this is what is the pattern of these are the possible strings in the language. So there should be equal number of A's and B's, and all A's should be preceding all B's, and there should be a center exactly in between the number of A's and number of B's. This is how the strings in this language are. Now, to design a push-down automata to accept all the strings in this language, we have an input tape and a stack. So let me take understand how to solve this particular or design a push-down automata for this particular language. We will take a string ACCBB. The string will be placed in the input tape. Let X be the pointer to the input tape and Y be the pointer to the stack. Initially Y will be pointing to Z0. Now, what is the logic? We have an input tape, we have a stack. So what we need to find out here is there should be equal number of A's and B's. So for every A there should be a B. How are we going to check that one? With the help of this input tape and stack. Whenever A comes in, you push it inside the stack. So what are we going to do? First X is reading a A. In that case, while as long as your X is going to read A, you are going to push it inside the stack. So first A, you will be pushing it inside the stack. So it will be coming like this. Now your Y will be pointing to this A. Now X will be pointing to this A. Now if second A it is coming, you will be pushing it inside the stack. Now when C comes, we understand that we are in the middle of the string. So next, when B comes, so no need to push or pop, just move the X pointer in the input tape. Now when B comes, for every B, if we start pop 1 then there are 2 B's. After B, the string ends, so we will be getting epsilon here. And if we are going to pop 1 for this B, if we have equal number of A's and B's, then after all the B's are popped out, for every B, if all the A's are popped out, we will arrive at a location where X is equal to epsilon and your Y is equal to Z0. This condition we can say as condition for acceptance. Now we can write an algorithm for this one. So what is our first step? While our X is equal to A, what are we going to do? We are going to push X and move X to the next state. Now if your X is equal to C, you are not going to push or pop anything. We can move X alone, input tape pointer alone to the next stage. Next, if you have, as long as you have X is equal to B and y is equal to a. So all the a's are now pushed inside the stack. For every b, we need to pop 1 1 a to check whether we have equal number of a's and b's. So while your x is equal to b and y is equal to a, you are going to pop y and move x. Now if we do like this, what will happen at the end? If your x is equal to epsilon and your y is equal to z0, you accept the string. Only if this condition prevails, we are going to accept the string. Now as long as, see, there is no explicit requirement to specify the state in push down automata, but for simplicity, let me assume all push is going to take place in state Q0, and the transition from Q0 to Q1 takes place when x is equal to c, and all pop let it take place in Q1, and let me accept our final state, let it be Q2. So now we need to give the transition table. So delta is the transition table. You will be looking at the current state. You will be also looking at your input tape symbols and stack symbols. By looking into all these things, you will be having some moves. So moves, what I mean, there will be some state transition as well as there will be some changes in stack. Either push or pop operation will take place. Okay. Now this is how we are going to define delta transitions. So let me fill the table. What is the initial condition? What is the possibility? Initial possibility, x taking a and y to be z0. So we are in state Q0. Your input tape will take a value, and if the stack is empty, there is a possibility to have z0. In that case, what to be done? We need to push that a inside the stack. So we are in the same state, remaining in the same state Q0, but this a, which is going to be the top of the stack, now replaced with a z0, making a as top of the stack now. That's what this 2 line means. Now what is the next possibility? You are in state Q0. If there is a possibility that there can be a possibility to have a and top of the stack and a coming in the input symbol. So in that case also you will be pushing. Okay, suppose the third a comes, this particular line will be executed, and say for example you have a power n, then this line will be executed once and this line will be executed n minus 1 times to push all the a's inside the stack. Okay, now what is the next possibility? When Q0 comes, c is the middle of the string, and a should be, this is the only possibility, a should be in the top of the stack. In that case, what are we going to do? We are going to make a transition from Q0 to Q1. So Q1, and you are not going to push anything or pop anything. The top of the stack a is going to be a itself. We are not pushing as we did it in the previous condition. Okay, so we are moving to the next state with no push or pop operation. Next is, we are in state Q1. The input tape is having a B and top of the stack is having a A. In that case, you have to pop. So you are popping off this A in top of the stack, so it gets replaced with epsilon. In that place of A, you don't have anything now. You just have epsilon. That is, that A is removed from the stack. That's what it means. Okay. Now, for n number of A, n number of B's, all that n number of B's, n times this line will be executed. And finally, you will be having Q1. All the B's are now traversed and it will be moving to the extreme right of the string. So we'll be having epsilon. And what should be here? If the string belongs to the language, then there should not be any A's left out in the stack. So the stack should have a Z0. In that case, you move to the accepting state and leave Z0 as such. So this is final state. So this is final state, acceptance by final state. Suppose we want to have an acceptance by empty stack, then let it be last condition Q1 epsilon Z0. This Z0 also has to be popped. So Q2 epsilon, you make it as Q2 epsilon. You are moving to final state and you are emptying the stack. This is empty stack method. Now this is the transition table. This is the transition table. Transition table. Now what is the transition diagram? We have three states. So you have a state Q0, you have one more state Q1, and Q2 is going to be your final state. Q0 is the initial state. So from Q0, if your tape is having a comma and your stack is having Z0, then you are going to push it. So A is Z0 and you are going to remain in the same state. Again, from Q0, if your tape is having a and stack top is having A, that case also you are going to push it. So A and remain in the same state. Now, when you are going to have a tape symbol as C, top of the stack as A, then you are not going to push or pop anything. You leave it A as such, A itself, and move to the next state, Q1. From Q1, if you are going to have a B in tape and A in top of the stack, then you have to pop off that A from the stack and you have to remain in the same state. Now from here, if you have epsilon in input tape and Z0 referring to the bottom of the stack, it means that it has reached the final, it has traversed through the entire string in the tape, also popped off all the A's for each B's in the tape. So in that case, you are going to move to the next state, that is the final state, and let it be Z0. So this is, I have drawn the diagram for final state method. Final state method, you can include for empty stack also Z0 comma epsilon. If it is going to be epsilon comma Z0, you can pop off that Z0 and say it is going to final state. This is the corresponding transition diagram. So this is the transition diagram.